Military trucks once hauled ammunition through mud while drivers hoped artillery wouldn't find them. Today's logistics platforms cost millions per unit, integrate battlefield networks, and survive direct mine blasts while coordinating supply chains across continents. The Oshkosh HEMTT exemplifies this transformation from vulnerable transport to protected command center. The HEMTT-A4 modernization turned a 1980s cargo hauler into a survivable logistics nerve center. Its 8x8 drivetrain and 515 horsepower Caterpillar engine handled 22,000 pounds of payload across any terrain. But the real evolution lies in protection and integration. Mine blast seats, armored cabs, and electronic warfare suites protect crews from improvised explosive devices that devastated convoys in Iraq and Afghanistan. The integrated battlefield management system transforms each truck from isolated transport into a network node, sharing position, cargo status, and threat data across the logistics chain. This evolution reflects how asymmetric warfare rewrote vehicle requirements. When insurgents turned supply routes into killing fields, militaries couldn't simply add armor to Vietnam-era trucks. They needed platforms that combined protection, payload, and digital integration from the ground up. The HEMTT's ability to survive attacks while maintaining supply flow determines whether forward bases hold or collapse. Modern warfare demands vehicles that think, communicate, and survive, not just haul. The Oshkosh HEMTT started as a simple cargo hauler in 1982, built to move supplies across desert terrain during Cold War deployments. 4 decades later, the A4 variant represents something fundamentally different, a survivable, networked logistics platform that costs up to $700,000 per unit. This transformation mirrors how military logistics evolved from basic transport to protected, intelligent systems that must survive in contested environments where supply convoys become primary targets. The 8x8 drivetrain configuration defines the HEMTT's capability foundation. Unlike conventional 6x6 trucks that bog down when terrain deteriorates, all 8 wheels provide independent traction through a sophisticated differential system. This means when the front axles encounter soft sand or mud, power automatically redistributes to maintain forward momentum. The 500 horsepower Caterpillar C15 diesel generates enough torque to push 17 tons of vehicle weight, plus 11 tons of cargo through conditions that would strand lighter trucks. Central tire inflation technology lets drivers adjust pressure on the move, dropping from highway pressures to 15 psi for sand operations without stopping the convoy. The A4 modernization program fundamentally changed what logistics vehicles must deliver. Mine blast protection now comes standard through V-shaped hull designs that deflect explosive force away from the crew compartment. The armored cab protects 3 occupants against small arms fire and artillery fragments, acknowledging that supply lines face direct attack. Electronic warfare packages jam roadside bomb triggers, while battle management systems track convoy positions in real time. These additions reflect Afghanistan and Iraq lessons, where unprotected logistics vehicles suffered catastrophic losses. The HEMTT now carries encrypted communications, GPS tracking, and threat detection sensors that would have seemed absurd on a cargo truck 20 years ago. Modern military operations demand logistics platforms that survive first contact. The HEMTT delivers fuel to forward operating bases under mortar fire, hauls ammunition through improvised explosive device zones, and recovers damaged vehicles while taking small arms hits. Its 10-ton payload capacity means fewer convoys exposed to enemy action. The vehicle's reliability across temperature extremes, from -40 to 120 degrees Fahrenheit, ensures supplies reach combat units regardless of conditions. This evolution from simple truck to armored, networked platform shows how logistics vehicles became combat systems themselves, essential to sustaining operations where every supply run faces deliberate interdiction. military planners discovered a fundamental problem with specialized vehicles. Every mission demanded different capabilities, but armies couldn't afford separate fleets for each task. The Rheinmetall MAN HX represents Europe's answer through radical modularity. Rather than building distinct vehicles for cargo, artillery towing, or command posts, this platform adapts its configuration to mission requirements. The base chassis accepts 4x4 through 10x10 drivetrain arrangements, scaling from 13-ton curb weight for reconnaissance to 28 tons fully loaded for heavy logistics. This flexibility means one production line supplies multiple battlefield roles. The 440 horsepower MAN D2066 diesel engine provides consistent power across all variants, though operators can specify the 540 horsepower D2868 for extreme payload requirements. Central tire inflation systems adjust pressure automatically based on terrain sensors, shifting from 60 psi for highways to 20 psi when crossing sand without driver intervention. Modern electronic architecture integrates battle management systems, encrypted communications, and diagnostic monitoring through standardized interfaces. The ergonomic cab design reduces driver fatigue during 24-hour operations while providing ballistic protection options. These systems work together to create a vehicle that reconfigures itself rather than forcing armies to maintain specialized fleets. Modular design transforms operational planning and logistics chains. Units swap container modules in 30 minutes, converting ammunition carriers into medical evacuation platforms or mobile command centers into fuel tankers. The 10x10 variant mounts artillery systems directly, eliminating separate gun tractors. This adaptability reduces the vehicle types armies must train mechanics to maintain, stock parts for, and transport to theaters. When NATO forces deploy, they bring fewer vehicle models but retain full mission capability. The $350,000 to $600,000 unit cost seems high until planners calculate the savings from eliminating multiple specialized vehicles. European armies operating HX2 fleets report 40% reductions in logistics footprint compared to legacy single-purpose vehicles. This shift from dedicated platforms to adaptable systems reflects modern warfare's demand for flexibility over specialization, where the same convoy might deliver supplies, evacuate casualties, and provide fire support within hours. The Me-26 Halo redefined what was possible for vertical lift, addressing the critical challenge of rapidly deploying massive payloads to inaccessible locations. As the world's largest series-produced helicopter, its introduction in 1983 marked a significant turning point in military and humanitarian logistics. This behemoth is powered by two turboshaft engines, each generating a staggering 11,400 horsepower, driving a unique 8-blade main rotor system with a 32-meter diameter. This engineering marvel allows the Me-26 to achieve an unprecedented 20-ton payload capacity, a feat underscored by its 1982 Guinness World Record for lifting over 56,000 kilograms to 2,000 meters. This immense capability translates directly into strategic operational advantages. Militaries gain the ability to transport main battle tanks, armored personnel carriers, and even other helicopters directly into forward operating bases, bypassing damaged infrastructure or hostile terrain. For rapid deployment scenarios, the Me-26 can carry up to 90 fully equipped troops, offering a swift and substantial insertion force. Beyond combat roles, its capacity proved invaluable in disaster response. During the Chernobyl catastrophe, Me-26s were instrumental, ferrying tons of building materials to construct the sarcophagus over the damaged reactor, a task few other aircraft could manage. This demonstrated how massive lift capacity could directly mitigate humanitarian crises by enabling critical logistical support under extreme conditions. The Me-26's sheer power and versatility transformed both military strategic mobility and the scope of humanitarian aid. It allowed planners to consider vertical transport for assets previously restricted to ground or sea, fundamentally altering logistical paradigms. This helicopter isn't just about moving heavy objects. It's about enabling operations that were once logistically impossible, providing a critical tool for rapid response and heavy-duty transport in the most challenging environments. Its enduring legacy is the benchmark it set for heavy-lift rotary-wing aircraft, proving that when size truly matters, the right engineering can overcome almost any obstacle. The Soviet Union's Ekranoplan Lun represented a radical departure from conventional naval thinking, exploiting ground effect physics to create a weapon system that defied traditional classification. Built in the 1980s, this 73-meter behemoth flew just meters above the water's surface, using 8 NK-87 turbojets to achieve speeds of 550 kilometers per hour, while carrying 6 P-270 Mosquet anti-ship missiles. The ground effect principle trapped air beneath its 44-meter wingspan, creating a cushion that allowed this 380-ton machine to skim the waves at aircraft speeds while remaining below most radar detection thresholds. This unique flight profile offered tactical advantages that conventional aircraft and ships couldn't match. Flying below typical radar horizons meant the Lun could approach enemy naval groups undetected until the final attack phase. Its 6 Mosquet missiles, each capable of destroying a destroyer-class vessel, could be launched from ranges that kept the Ekranoplan outside most defensive weapon envelopes. At 550 kilometers per hour, it moved 3 times faster than conventional warships, while carrying firepower comparable to a missile corvette. The combination of speed, stealth profile, and heavy armament theoretically enabled a single Lun to threaten entire carrier battle groups, arriving too fast for traditional naval defenses to react effectively. Despite these revolutionary capabilities, only one Lun ever entered service before the Soviet collapse ended the program. The platform demanded specialized maintenance facilities, unique pilot training combining aircraft and ship operations, and infrastructure investments that proved unsustainable. Operating restrictions limited it to relatively calm seas, reducing its strategic flexibility compared to traditional naval assets. Today, the sole completed Lun serves as a museum piece in Derbent, Russia, a monument to an engineering philosophy that pushed beyond conventional boundaries. The Ekranoplan concept demonstrated that radical innovation could create entirely new combat paradigms, but also revealed how operational complexity and economic reality ultimately determine which technologies reshape warfare. The Lun remains unmatched in its specific capabilities because no nation has attempted to replicate this extreme approach to naval strike warfare, leaving it as both a technical triumph and a strategic dead end that almost revolutionized how navies think about speed, stealth, and striking power. The Typhoon-class submarine represents the absolute zenith of Cold War engineering, where the drive for nuclear deterrence dictated unprecedented scale. These vessels, designated Project 941 Akula, were constructed to dwarf all existing naval platforms, displacing 48,000 tons while submerged. Measuring 175 meters in length and 23 meters in beam, the Typhoon was specifically engineered as a direct Soviet counter to the American Ohio-class ballistic missile submarines. At the heart of its capability were 20 R-39 submarine-launched ballistic missiles, each capable of striking targets 8,000 kilometers away. This massive arsenal, paired with a dual nuclear reactor propulsion system, allowed these submarines to remain submerged for up to 6 months, providing a near-invulnerable second-strike capability that defined the era's strategic balance. Beyond mere size and destructive power, the Typhoon was designed to sustain its crew during these months-long patrols in the harsh Arctic environment. To maintain operational readiness and morale, the interior layout included amenities unheard of in naval architecture at the time, such as a gymnasium, a swimming pool, a sauna, a cinema, and even a small birdhouse. This focus on long-term habitability was essential for a crew of 160, who operated the complex sonar, missile, and reactor systems. By integrating these life support features directly into the hull, the Soviet Union ensured that their most potent deterrent could remain at sea indefinitely, ready to launch at a moment's notice. The legacy of the Typhoon is one of engineering extremes. While 6 units were built, the high cost of maintenance and the shifting strategic landscape eventually led to their withdrawal from active service. The final unit, TK-208 Dmitry Donskoy, served for years as a critical test platform for new ballistic missile technologies before being decommissioned. These submarines proved that when survival and deterrence are the primary objectives, engineering constraints can be pushed to their absolute limit. They remain the largest submarines ever constructed, serving as a permanent monument to a period when global stability rested on the silent, submerged presence of these massive, self-contained fortresses. Their retirement signals a shift toward more agile, cost-effective underwater platforms, moving away from the era of massive, singular deterrence toward a more distributed naval strategy. While the era of massive, singular deterrence like the Typhoon submarines concluded, a new form of naval innovation emerged, challenging conventional shipbuilding and budgetary limits: the Zumwalt-class destroyers. These vessels represented a radical departure in surface warfare, designed to integrate cutting-edge technology with unprecedented stealth capabilities. Their distinctive tumble-home hull design was engineered to minimize radar cross-section, making these large ships appear as small fishing vessels on enemy radar, offering a significant advantage in contested environments. Beyond their stealth profile, the Zumwalts were pioneers in automation. Their highly integrated combat systems allowed for a dramatically reduced crew of approximately 140 personnel, a fraction of traditional destroyers. This automation aimed to lower operational costs and improve efficiency, but also introduced immense complexity. Furthermore, the destroyers featured an advanced electric propulsion system, specifically designed to generate sufficient power for future energy-based weapons, such as railguns and high-energy lasers. This forward-thinking design positioned them as potential platforms for next-generation armaments, promising a leap in naval firepower. However, this ambition came with a staggering price. Each Zumwalt-class destroyer carried a unit cost exceeding $4 billion, making them the most expensive destroyers ever built. This exorbitant price tag, combined with technical challenges and the high cost of specialized ammunition for their advanced gun systems, severely curtailed the program. Initially planned for 32 ships, only 3 were ultimately commissioned, with the AGS guns eventually rendered non-operational due to ammunition expenses. The Zumwalts exemplify the tension between revolutionary technological advancement and the hard realities of military budgets and operational viability, proving that even the most innovative designs can be constrained by economic and practical limitations. The Oshkosh M1070 Heavy Equipment Transporter represents the critical evolution of logistics, shifting from simple supply trucks to specialized platforms engineered to move the modern battlefield's most daunting assets. As main battle tanks like the Abrams grew in weight and complexity, military transport had to scale accordingly. The M1070 was developed specifically to handle this surge in mass, boasting a 70-ton payload capacity that allows it to haul heavy armor across diverse terrain. Under the hood, a 700-horsepower Caterpillar engine provides the necessary torque to pull massive loads, while an 8x8 drivetrain ensures that these heavy haulers maintain mobility in environments that would immobilize standard commercial vehicles. The performance implications of this design are rooted in survivability and operational endurance. Unlike legacy transporters, the M1070 features an armored 6-person cab, protecting the crew and the vital logistics operators from ballistic threats and improvised explosive devices. The integration of the central tire inflation system allows drivers to adjust tire pressure on the fly, optimizing traction for soft sand or rugged off-road conditions without stopping the convoy. The M1070A1 upgrade further refines this capability, introducing enhanced drive systems and modernized electronics that improve reliability and diagnostics during extended deployments. These technical refinements ensure that the heavy armor reaches the front line ready for combat, rather than suffering from mechanical fatigue during transit. Practically, The M1070 is the backbone of heavy maneuver warfare. By providing a dedicated, hardened platform for transporting tanks, the military avoids the excessive wear and tear on tank tracks and engines that would occur during long-distance road marches. This logistical efficiency is a force multiplier, preserving the combat readiness of the primary fighting vehicles until they are needed at the point of contact. The HET is not just a truck. It is a strategic asset that bridges the gap between a base of operations and the tactical front. As we pivot toward the massive power projection required by modern carrier strike groups, the ability to move heavy assets with such precision remains a foundational requirement for global reach. This reliance on heavy logistics sets the stage for the ultimate expression of power projection, the modern nuclear-powered aircraft carrier. The Gerald R. Ford-class represents the culmination of 70 years of carrier evolution, where electromagnetic catapults replaced steam systems that had defined naval aviation since World War II. At $13 billion per hull, these platforms embody a fundamental shift in how navies project power, not through more ships, but through radical technological integration that multiplies the capability of each vessel. The electromagnetic aircraft launch system fundamentally changes carrier operations. Unlike steam catapults that require massive boiler systems and complex piping, EMALS uses linear motors to accelerate aircraft with precise control. This allows launching lighter unmanned vehicles without damaging their airframes, while also handling the heaviest strike fighters at maximum payload. The system reduces stress on aircraft by 30%, extending their service life and reducing maintenance cycles. With 75 aircraft capacity and the ability to generate 160 sorties per day, 33% more than Nimitz-class predecessors, the Ford transforms from a floating airfield into a sustained air campaign platform. Nuclear propulsion defines the strategic equation. The twin A1B reactors generate 600 megawatts of electrical power, 3 times the Nimitz output, while requiring no refueling for 25 years. This electrical abundance powers not just propulsion, but future directed energy weapons and advanced radar systems. The automation reduces crew requirements from 5,000 to 4,600, cutting operational costs by $4 billion over the ship's 50-year lifespan, despite the massive upfront investment. The practical reality is that one Ford-class carrier projects more combat power than most nations' entire air forces. The combination of electromagnetic launch, nuclear endurance, and automation creates a mobile sovereign territory that can sustain air operations indefinitely, anywhere within reach of ocean. When diplomatic negotiations stall, the arrival of a carrier strike group fundamentally alters regional calculations. The $13 billion price tag reflects not just steel and systems, but the ability to enforce international order without forward bases or host nation permission. This represents the apex of military vehicle evolution, from trucks protecting supply lines to floating cities that project national will across oceans. The Ford-class embodies how modern military platforms have transcended transportation to become instruments of geopolitical influence. These 8 platforms trace military evolution from basic utility to strategic dominance. Each breakthrough answered specific battlefield failures. The HEMTT's armor stopped convoy massacres. The Mi-26 lifted impossible loads from disaster zones. The Ekranoplan challenged naval detection. The Typhoon enforced nuclear stalemate. The Zumwalt pursued invisibility at 4 billion per hull. The M1070 moved 70-ton tanks at highway speeds. And the Ford-class compressed entire air wings onto nuclear-powered steel. Today's arsenal exists because yesterday's vehicles couldn't survive modern threats. Every billion spent represents lessons written in operational failure and strategic necessity.